Welcome to the deep dive. Today, we're going to be tackling something that you might not have thought much about: packed bed scrubbers. These things are quietly working hard to keep our air clean, and I, for one, am really excited to kind of dig into this and learn more about it with you today.
They're like the silent guardians of clean air.
Exactly. So we're diving into this topic with insights from a YouTube video by Torch Air Scrubber, Baghouse Pollution Control. And they do a really good job of breaking down how these scrubbers work, what are the design choices that really make a difference, and just the whole world of packing materials. By the end of this, we'll both have a whole new level of appreciation for these behind-the-scenes heroes. Ready to get started?
Absolutely.
Okay, so before we get into the nitty-gritty, let's start with the basics. What does a packed bed scrubber actually do? Why are these things so important?
Well, imagine a factory releasing potentially harmful gases into the atmosphere. A packed bed scrubber is designed to capture those gases before they reach the outside air. Think of it as a giant air filter, but instead of a simple filter, it uses a liquid to trap the pollutants.
So it's like giving those dirty emissions a shower before they're released into the environment.
That's a great way to put it. And to make this shower as effective as possible, we need to maximize contact between the gas stream carrying those pollutants and the scrubbing liquid. The key here is surface area. The more surface area we have, the more opportunity for the liquid to capture and neutralize those pollutants.
So it's kind of like trying to catch as many raindrops as possible with a large sheet compared to a small cup, right?
All right.
More surface area equals more chances for contact. But if we're talking about airflow, surely too much resistance would be a problem, wouldn't it?
You're exactly right. It's a delicate balancing act. That's why gas and liquid flow rates are so crucial in scrubber design.
I see. You want enough contact time for that cleaning to happen, but not so much that it restricts the flow or creates too much pressure. It's like finding the Goldilocks zone of flow rates. Not too fast, not too slow, just right for efficient cleaning.
That's a perfect analogy. It's a delicate balance between efficiency and flow.
Okay, now I'm curious about the size of these scrubbers. I'm picturing a towering structure, but is taller always better? Like, would a skyscraper-sized scrubber be the most efficient?
That's a common misconception. While a taller tower does provide more contact time between the gas and liquid, it's not a one-size-fits-all situation.
So there's more to it than just building the tallest tower possible. What other factors come into play?
Well, the optimal tower size depends heavily on those flow rates we just discussed, as well as the specific pollutants being targeted. Building an unnecessarily tall tower could be wasteful and inefficient.
So it's about finding the sweet spot between maximizing contact time and keeping the whole system practical.
Makes sense. Now, I'm really interested in the heart of the scrubber, where the magic happens, the packing material. From what I've gathered, there's a whole world of different packing materials out there.
There is. It's an area where engineering ingenuity really shines. Choosing the right packing material is absolutely vital for the scrubber's performance. It's not just about providing surface area. We also need to consider durability, especially in those harsh industrial environments where these scrubbers operate.
Okay, so it's got to be tough enough to handle corrosive gases, chemicals, and even high temperatures.
Exactly. Corrosion resistance is paramount. We often use materials like stainless steel, polypropylene, or other chemical-resistant plastics, depending on the specific application.
So it's like choosing the right armor for your scrubber, making sure it can withstand the onslaught of those nasty pollutants. But I imagine there's not a one-size-fits-all material, right? What are some of the different types of packing materials used in these scrubbers? That's where it gets really interesting. There are so many different types of packing materials, each with its own unique advantages and ideal use cases. We have everything from simple designs like rashig rings, which are like little donuts, to more intricate structures like interlock saddles, which resemble, saddles.
Interlock saddles? I'm already picturing tiny horses riding through those scrubbers. But seriously, what makes each of these materials special? I mean, why wouldn't you just use the one with the most surface area all the time?
That's a great question. While maximizing surface area is important, other factors come into play, like pressure drop, cost effectiveness, and suitability for specific applications.
So there's a trade-off between maximizing contact and maintaining flow efficiency.
Exactly. And each material has its own strengths and weaknesses in that regard.
Okay, let's dive into some of these different types then. First up, we have the rashig rings, those little donuts you mentioned. Are these the go-to choice for most scrubbers?
They're kind of the OG of scrubber packing. They're known for their durability, especially in high temperature and corrosive environments. They're also relatively inexpensive.
So a solid, reliable choice for simpler setups. But you mentioned they're not always the most efficient. Are there situations where they fall short?
Well, while reliable, Rashig rings aren't necessarily the most efficient option available today. Their simple design can lead to higher pressure drops compared to some of the newer options out there.
Okay. So what are some of these newer, more efficient options that might outperform the classic Rashig rings?
Well, let's talk about Pall rings. They're a bit more complex in design than Rashig rings, featuring a more open structure that helps to improve flow.
So they offer more surface area for contact while minimizing that pesky pressure drop.
Exactly. And they're incredibly versatile. You can find Pall rings made from polypropylene, metal, or ceramic, making them suitable for a wide range of industrial conditions.
So it sounds like Pall rings might be the Swiss Army knife of scrubber packing materials. They can handle just about anything you throw at them. What other intriguing designs are out there in the world of scrubber packing materials?
We have something called saddle packing, which, as the name suggests, is shaped like a saddle.
Okay, now I'm picturing a miniature rodeo inside the scrubber. But seriously, what's so special about this saddle shape?
Well, that unique shape provides some interesting benefits. Saddle packing offers both a low-pressure drop, AD, a high surface area, making it quite efficient.
So it's another option for maximizing contact while minimizing resistance.
Precisely. And the shape also helps to distribute the scrubbing liquid more effectively and reduces the risk of blockages within the scrubber bed.
That's really clever. It's amazing how much thought goes into designing these seemingly simple components. Now, what about structured packing? That sounds pretty high-tech compared to rings and saddles.
It is. Structured packing is a bit more complex and expensive. It's made up of thin, corrugated sheets, carefully arranged to create a highly efficient surface for gas-liquid contact. Think of it like taking those basic shapes, rings, saddles, and engineering them to a whole new level of performance.
So it's like the luxury sports car of scrubber packing materials, high performance, but maybe not suitable for every situation.
That's a good analogy. Structured packing is particularly effective for processes that require very high mass transfer efficiency, like those involving complex chemical reactions.
Okay, so for those situations where you need the best of the best, structured packing is the way to go. But what about simpler, more cost-effective options? What about something like plastic balls?
You'd be surprised how effective something as simple as plastic balls can be. They provide a surprisingly large surface area and are a very cost-effective solution for less corrosive environments.
So they might not be the most sophisticated option, but they get the job done in certain applications. It's like saying, hey, sometimes a bouncy castle is just as fun as a fancy amusement park ride.
Exactly. Sometimes simplicity wins.
And I'm guessing there are even more variations out there. What about interlock saddles? They sound related to those standard saddles we talked about earlier.
You're right. Interlock saddles are like the Saddle Packing Plus. They offer even better performance with minimal pressure drop.
So they took the already efficient saddle design and made it even better. That's really impressive. It sounds like choosing the right packing material is like navigating a maze of options. So much to consider.
It can be.
Yeah.
There are so many factors to consider. The type of gas being treated, the contaminants involved, the desired level of efficiency, the operating environment, and of course, budget considerations. It's not as simple as just picking the one with the most surface area.
You've definitely painted a vivid picture of that complexity. It's really fascinating how much thought goes into selecting the right packing material. So before we move on to the next part of our deep dive, I'd love to get your expert opinion on something. If you were advising someone on choosing a packing material, what key factors would you tell them to consider?
That's a great question. Let's pause here and pick that up in part 2 of our deep dive. Welcome back to the deep dive. When we left off, you were about to give some expert advice on how to choose the right packing material for a specific application.
That's right. I'm ready to hear your wisdom on navigating this maze of options. What are the key things someone should keep in mind when making that decision?
Well, first and foremost, you need to consider the nature of the gas stream you're dealing with. What kind of pollutants are present? Are we talking about corrosive gases, volatile organic compounds, or something else entirely? The chemical composition of the gas stream will dictate the type of material that can withstand the environment.
So it's like matching the material's armor to the specific weapons of the pollutants, right? Making sure it can handle the attack.
Exactly. Then you need to think about the desired level of efficiency. How clean does the gas stream need to be before it's released? If you're dealing with highly stringent emission standards, you might need to opt for a more efficient packing material, even if it comes at a higher cost.
So sometimes you need to bring out the big guns like structured packing to achieve those really tight emission targets.
That's right. But if the application is less demanding, you might be able to get away with a simpler and more cost-effective option, like Rashik rings or Pall rings. And of course, the operating environment plays a significant role. Is the scrubber operating at high temperatures? Are there abrasive particles in the gas stream? These factors will influence the material's durability and lifespan.
So you need a material that can not only withstand the chemical attack of the pollutants, but also handle the physical stresses of the environment. It's like a double whammy of challenges. And I imagine budget considerations are always a factor as well.
Absolutely. As with any engineering decision, cost is a crucial consideration. You need to find the right balance between performance and affordability. Sometimes a simpler material like those plastic balls we talked about might be the most cost-effective solution, even if it's not the most efficient.
It all comes back to finding that sweet spot between efficiency, durability, and cost-effectiveness. It sounds like a real puzzle.
It is. But that's what makes it so challenging and rewarding.
Okay, I think I'm starting to get a handle on the factors involved in choosing the right packing material. It's like a detective case, piecing together all the clues to find the perfect solution.
I like that analogy. And speaking of detective work, you mentioned earlier that you were curious about where packed bed scrubbers are actually used in the real world.
Oh, yeah. I was picturing them mainly at factories with big smokestacks, but I bet they have a much wider range of applications than I initially imagined. Where else might we find these silent guardians of clean air hard at work?
Well, you're right. They're often found at factories and industrial plants that release emissions as part of their processes. They're common in chemical processing plants, power generation facilities, and even pharmaceutical manufacturing.
So anywhere where there's a risk of releasing harmful gases into the atmosphere.
Exactly. They're essential for controlling emissions from things like boilers, incinerators, and various industrial processes that produce those nasty pollutants we talked about. Volatile organic compounds, acid gases, and particulate matter.
Wow, that's a much broader range than I initially realized. They really are the unsung heroes of environmental protection, quietly working behind the scenes to keep our air breathable. It's like having a team of tiny ninjas scrubbing the air clean before we even know it's dirty.
I like that image. And what's even more interesting is that packed bed scrubbers aren't limited to just industrial applications.
Oh. Really? Tell me more. Where else might we find these versatile scrubbers?
Well, they're also used in some pretty unexpected places like wastewater treatment plants.
Wait, so they can scrub water too? I thought they were just for air.
They can. In wastewater treatment, packed bed scrubbers are used to remove odors and harmful gases that can be released during the treatment process.
That makes sense. Wastewater treatment can get pretty smelly, so having a scrubber to handle those odors would be a big win for nearby residents.
Exactly. And believe it or not, they're even used in some agricultural settings.
Agricultural settings. Now that's really surprising. I can't imagine what they'd be scrubbing there.
Well, in livestock facilities, for example, packed bed scrubbers can be used to control ammonia emissions, which can be a significant air quality concern.
Wow, I never would have thought of that. So they're protecting our air from factory emissions, wastewater treatment odors, and even livestock smells. It's like they've got our backs no matter where those nasty gases are coming from.
They do, and I think that speaks to the versatility and adaptability of this technology. Packed bed scrubbers can be tailored to fit a wide range of applications, from heavy industry to agriculture and beyond.
It's incredible how adaptable they are. So we've talked about how they work, the different types of packing materials, and their diverse applications. But I'm also really curious about the future of packed bed scrubbers. Are there any exciting new developments on the horizon? Will they still be around in the future, or will they be replaced by something even more amazing?
That's a great question and a perfect segue to the final part of our deep dives.
Welcome back to the deep dive. We've explored how packed bed scrubbers work, the fascinating world of packing materials, and their surprisingly diverse applications. Now I'm really excited to delve into the future of this technology. Are packed bed scrubbers here to stay, or will they be replaced by something even more amazing?
Well, I think it's safe to say that packed bed scrubbers have earned their place as a cornerstone of air pollution control. But the field is constantly evolving, driven by the need for even greater efficiency, lower operating costs, and stricter environmental regulations.
So they're not resting on their laurels. What are some of the exciting developments that might shape the future of packed bed scrubbers? What should our listener keep an eye on?
One area that's really heating up is the development of new packing materials. Researchers are constantly searching for materials that offer even higher surface areas, lower pressure drops, and enhanced durability. Imagine packing materials so efficient that they can capture even the tiniest pollutants with minimal resistance to flow.
Wow, it's like the quest for the ultimate scrubber packing. What kind of materials are they exploring? Are we talking about some kind of space-age polymers or something?
You're not far off. They're looking at advanced polymers, ceramics, and even hybrid materials that combine the best of both worlds. These new materials need to be tough enough to withstand increasingly harsh conditions, like highly corrosive gases and extreme temperatures.
It's like designing armor for a microscopic battle against pollution. But it's not just about materials, right? What about the design of the scrubbers themselves? Are there any innovations on that front?
Absolutely. Engineers are using sophisticated computer modeling techniques like computational fluid dynamics to optimize scrubber design. These simulations allow them to visualize how gas and liquid flow through the scrubber, helping them fine-tune the shape, size, and internal configuration for maximum performance.
So it's like they're building virtual scrubbers in a computer to test out different designs before they even build the real thing.
Exactly. It's like having a virtual wind tunnel for scrubbers, allowing engineers to experiment with different configurations and find the most efficient designs.
That's incredible. It seems like a perfect blend of cutting-edge technology and environmental responsibility.
It is. And let's not forget about the growing emphasis on sustainability. There's a big push to make these scrubbers even more environmentally friendly. Imagine scrubbers that use less energy, minimize water consumption, and even incorporate recycled materials.
So it's about making sure these pollution control devices themselves don't contribute to the problem.
Exactly. It's about creating a more sustainable and holistic approach to air pollution control.
That makes perfect sense. Now, you mentioned something earlier about smart sensors and automation. That sounds straight out of science fiction. Are we talking about self-aware scrubbers that can adjust themselves on the fly?
It might sound futuristic, but it's closer than you think. The integration of smart sensors and automation technologies has the potential to revolutionize scrubber operation. Imagine scrubbers that can monitor their own performance in real time, detect changes in the gas stream, and automatically adjust their operating parameters to maintain optimal efficiency.
Wow. It's like giving the scrubber a brain. What kind of benefits could we see from this level of intelligent automation?
Well, for starters, it could significantly enhance scrubber efficiency, ensuring that they're always operating at peak performance. It could also reduce downtime by predicting maintenance needs before problems arise. And it could even help lower operating costs by optimizing energy and water usage.
So it's a win-win-win situation. Better performance, less downtime, and lower costs, all thanks to intelligent automation. It's amazing how technology is transforming even something as seemingly simple as a packed bed scrubber.
It is. And I think these advancements highlight the convergence of engineering, environmental science, and technological innovation that's happening in this field.
We've certainly seen that convergence play out throughout our deep dive. From the ingenious designs of those packing materials to the sophisticated computer models used to optimize scrubber performance, it's clear that a lot of brilliant minds are working to make our air cleaner.
That's right. And it's not just about making scrubbers more sophisticated. It's ultimately about protecting our environment and ensuring cleaner air for everyone.
Well said. So for our listener who might be feeling inspired by this deep dive, what would you say is the most important thing to remember about packed bed scrubbers?
I think the most important takeaway is that packed bed scrubbers are much more than just simple pollution control devices. They represent a remarkable blend of engineering ingenuity, environmental responsibility, and technological innovation, all working together to address one of the most pressing challenges of our time: clean air.
That's a fantastic takeaway. It's been a real eye-opener for me, and I hope our listener feels the same way. It's made me realize just how much innovation and ingenuity goes into cleaning up our air. I'll never look at a factory smokestack the same way again.
I'm glad to hear that. It's been a pleasure exploring this fascinating topic with you and our listeners.
Likewise. And to our listener, thank you for joining us on this deep dive into the world of packed bed scrubbers. We hope you've gained a new appreciation for these unsung heroes of clean air. Until next time, keep exploring, keep learning, and keep breathing that clean air.